Hey guys, welcome back to Click Academics. In today's video, I'm going to be solving an interesting system of equations. So for my first equation, I have 10x squared plus 10y squared is equal to 29xy. And for my second equation, I have x squared minus y squared is equal to 21. So using these two equations, I want to find the value of x plus y. So I'm going to first start with my first equation over here. So equation 1, I have 10x squared plus 10y squared is equal to 29xy. What I'm going to do is divide both sides by 10. So I get x squared plus y squared is equal to 29 over 10 times xy. Now, our second equation is x squared minus y squared is equal to 21. So what I'm going to do is if I have something in the form a plus b squared, this is equal to 4ab plus a minus b squared. So in this case, I'm going to let a equal to x squared and b equal to y squared. So I get x squared plus y squared squared, in this case a is x squared, b is y squared again, is equal to 4 times x squared times y squared plus x squared minus y squared squared. So now I get 29 over 10 times x times y squared, which is the value of x squared plus y squared squared, is equal to 4x squared times y squared plus 21 squared, which x squared minus y squared is equal to 21. So now I have 29 squared over 10 squared times x squared times y squared is equal to, or I'm just going to bring everything to the left-hand side, so I get minus 4x squared y squared is equal to 21 squared. And this means that x squared times y squared times 841 minus 400 over 10 is equal to 21 squared, which is 441. And if you're confused about how I got this, I just factored out x squared times y squared. So I get x squared times y squared times 841 minus 400 over 10 is equal to 441. And this turns into x squared times y squared times 441 over 100 is equal to 441. So now these two cancel out, and I get x squared times y squared is equal to 100. And now if I take the square root on both sides, I get x times y is equal to positive or negative 10. So this means that x times y is equal to 10, or x times y is equal to negative 10. But now remember how x squared plus y squared is equal to 29 over 10 times x times y. So this means that I get two cases, one with x times y equaling 10, one with x times y equals negative 10. So for case 1, I have x squared plus y squared is equal to 29 over 10 times 10. Our first case is x times y equals 10. So then these two cancel out, and I get x squared plus y squared is equal to 29. Now for case 2, I have x squared plus y squared is equal to 29 over 10 times negative 10. So in this case, x squared plus y squared is equal to negative 29. So right here we have a contradiction because x squared plus y squared has to be greater than 0 because anything squared is positive. So a positive number plus a positive number has to be positive. So this is greater than 0, but then we have a negative number here, which is less than 0. Meaning, there's no solution for this. So, we only have our left-hand side equation left. So now I have x squared plus y squared is equal to 29. And I'm also going to use this, x times y equals 10. So now we've gotten another system of equations, but this one is a little easier to solve. So again, remember, I want to find the value of x plus y. That's my goal. So now I'm going to use the property a squared plus b squared is equal to a plus b squared minus 2ab. So in this case, x plus y squared minus 2x times y is equal to 29. And this also means that x plus y squared is equal to 29 plus 2 times xy. Now x times y equals 10, so I have x plus y squared is equal to 29 plus 2 times 10, meaning x plus y squared is equal to 49. So now if I take the square root on both sides, I get x plus y is equal to positive or negative 7, meaning that x plus y is equal to 7 and x plus y is equal to negative 7. So these are my two solutions. And again, this was rejected because we have one side that's greater than 0, one side that's less than 0, so we can't use that. So what we did was we started with a large system of equations, and then we simplified that to something a little more simpler, and then we used that to get our solutions right here. So yeah, these are our two solutions to this system of equations.